Now, talking about the transfer of heat, we know that transfer means when it passes from one to the other object. So, how does the heat passes from one object to the other object? That is what the transferring of heat. So, to carry heat energy, from one part of an object to its other part, or from one object to another object. So in the transferring of heat, either what happens, either the heat energy passes from one part of an object to the other part, or it passes from one object to the other object, and it is called as the transfer of heat. It's called as transfer of heat. Now, Varshit and Kritvik, can you give me like any examples where you can find this transfer of heat?
Like cooking.
In
When we cook items.
cooking. Okay. Right. When we cook items, then what happened? Basically, we'll be using the utensils, right? And while using those utensils, the transferring of heat will be there. In that also, we have the different ways. Like maybe sometimes what happened when we switch on the flame. So initially, the pan will get hot, right? The center part of it will start heating up. Later on, we can see that the handle of the pan also gets hot after some time, right? So different ways are there of transferring the heat from one object to the other object. So those methods we will be discussing, and these are called as the modes of heat transfer. So there are three different ways. What are the three different ways? How does the energy transfer?
Then conduction.
Yes.
Radiation.
Yeah, conduction, radiation, and
Conduction.
yeah, conduction, convection, and the radiation. These are the three ways by which the transferring of heat take place. Now, out of all these three, these are like very simple in the basic things. Out of these three, one is depending on the radiations. Like you might have seen the oven, microwave oven. What happened in that? The radiations from the microwave will come on the food item, whatever we want to cook. So that is what the radiation. Whereas in the conduction, what happens? What kind of molecules will be there? The solid particles will be there, right? Like for example, now I want to prepare the omelette. All right. I want to prepare the omelette. What happens is there? The base is what? A solid, right? Now, when we are keeping the omelette, the eggs we are keeping there for making the omelette, that is also like will be turned up to a little of solid. So, solid and solid connection, that is called as the conduction. Whereas in the convection, the heating up of the molecules. So molecules were initially down at the layer, but later on, because of the heat energy transfer, it has reached up and up, like in the form of the land breeze and the sea breeze. So in the land and sea breeze, what happens? The water molecules will start heating up. They goes up into the sky, then they comes down in the form of the rain. So those things keep on repeating. So in the case of the convection, it is in the form of the liquid, where the liquid gets heated up. Whereas in the conduction, it is solid and solid material where they are coming in contact to each other. And in the form of radiations, the radiation energy will be working. Right? So we'll discuss one by one all these ways. So this is transferring of energies basically when from one part of the object transfer to the other part of the object, or from one part of the object to the other part of the object, it gets transfer. Now, how does heat flow? How does heat flow? So basically this flow by through the mode of heat of transfer. So the mechanism
We are not sharing screen.
Okay, let me see. Okay, I think now it is visible.
It's not visible.
So the mechanism by which heat is transferred from one region to another region, that is called as the modes of heat transfer. So the mechanism by which the transferring of heat or the flow of heat takes place, that is called as the modes of heat transfer. Now there are three different modes of it, so which we have discussed right now, which are the conduction, convection, and the radiation. So these are the three modes of heat transfer: conduction, convection, and the radiation. Starting with the first one, conduction, it is the transfer of heat from a hotter part to a colder part of an object. So now, like as I have discussed right now, if a pan is there, what happened? The flame will be coming up, right? The flame will start coming up to the pan. Now this becomes hot, and this will be transferring all the kind of the heat energy to the egg, and that is why slowly and gradually what happened, it turns into the omelette. So this what happened, the transferring of heat will be there from the hotter part to a colder part of an object. Now why it happens? It happens due to collision of its particle. So what do you mean by collision?
Colliding.
Yeah, colliding. So basically the colliding, they just collide with each other, they just come close to each other, they collide with each other without actual movement. They do not move from their place, they will be at their place only, and they will start colliding. So this happens because of the colliding of its particle without the actual movement of the particles from their position. So wherever the molecules are there, they will be standing there itself without moving. What do? They just collide from each other and they just pass the heat energy. So in this, what happened? It occurs between solid to solid substances. So whatever the solid and solid substances are there, they will be having this conduction process. I'll show you a video now related to this where you can find out the way how they transfer the energy. So the molecules will be at their places only, they will not be moving, but yes, at the same time, they will be colliding with each other. And because of this collision only, so molecules are here. What do they do? They are like, we know very well, in the solid, the molecules will be tightly packed or the loosely packed?
Tightly packed.
Tightly packed, right? So all the molecules are like several tightly packed in this case. Now what happened, as soon as the heat is coming up, they cannot move from place to place because they are very tightly packed. So that is why they will be just colliding, and because of the collision, the transfer of heat will be done. So look at this video.
In our previous video, we discussed how heat, also known as thermal energy, is responsible for changing the behavior of molecules in a pure substance and how that energy can result in the substance changing its state of matter. But here are two questions. First, can you explain how thermal energy moves from a heat source to another substance? Additionally, are there any materials that can withstand high temperatures? I am curious to learn more about this topic, so let's get right to it. As a reminder, the term heat, used in everyday language, refers to thermal energy, which is the motion of atoms or molecules within a substance. Heat also refers to transferred energy, which we will discuss today. Heat can be transferred through convection, conduction, radiation, or a combination of these methods. It is important to remember that each process involves sending thermal energy from a warmer substance to a cooler one.
So whether it is the conduction, whether it is convection, or whether it is radiation, always keep in mind the movement will be there from the hotter to a colder part. Like if I talk about sun radiations also. So the radiation of sun are hot. So they come to the colder part, which is on us. And then in microwave also, the radiations are hot. So those hot radiation comes on the food item, whatever we keep it inside the microwave.
Start with convection. This process occurs when hotter material moves towards cooler areas, displacing the cooler material and causing heating. An example of this is boiling water.
Convection is basically when the hot materials, they will be flowing to the cool material, and because of this, what happened? Whatever the cooler material is there, it starts heating. It's become hot in nature. For example, now if I want to boil the water, initially it was cold, but slowly and gradually, though, that water will be turning into the hot water.
In a pot. The hotter water at the bottom rises to the surface, carrying heat with it.
So you might have noticed also, like if we have so much of water in a container, initially the down molecules will be becoming hot, and slowly and gradually those hot particles or the hot molecules will go up, and it will make the upper surface also hot.
This causes the contents of the pot to heat up and cook. The cooler water then falls to the bottom and is heated, restarting the cycle.
So this is what happened. Down part will be heated up first, then it goes up. From the up, the cooler one will come down. Then from down, the hotter one goes up. Then cooler one come down, the goes up. So like this, it keeps on going until the equilibrium state comes. Now, what does the equilibrium state means here? What does equilibrium means? Like I am saying, the hotter part, the hotter liquid is going like from down, it is coming up, and from up, the colder water is going down to the hotter area. Then again from the down, the hotter water is going up in the colder area. Then from up, the cold water is coming down to the hotter area. So like this, the movement is keep on going until the equilibrium state comes. What do you mean by equilibrium state?
Ma'am, both are of same temperature.
Very good, Varshit, very good. It means when both, like not both actually, when the whole amount of water comes to a constant temperature. So that state when the water has a particular temperature, whether it is the down water, whether it is the top bottom water, whether it is the middle water. So all these zones of the water has the same temperature. That moment it comes under the equilibrium state. So when we turned on, what happened? Only the down portion of the water was heated up. But later on, due to movement between down layer and upper layer, down layer and upper layer, upper to the down layer, what happens? A state has come where all the layers of that water has turned into the equilibrium state.
The second type of thermal energy transfer is through the process of conduction. In this method, heat is transferred when a material comes into direct contact with a heat source. You can observe this when cooking on a stove, where the bottom of a pan comes into direct contact with the heat source. The stove conducts heat energy directly to the bottom of the pan, and then the pan conducts heat energy directly into the food touching it. This is how an egg is fried and how a burger.
So directly what is happening, the heat energy is coming in contact with the solid particles and they will be heated up.
Is cooked on a grill. Moving on, the third method of heat transfer is radiation. In this process, heat is transferred without substances or matter moving or touching. Instead, the heat moves through the space between the heat source and the object to be heated. the object in the path of the radiation will be heated. For instance, the sun uses this method to heat all the planets, including Earth. Similarly, when we broil or bake something, the heat source in the oven sends heat energy through the space between it and the baking item. The heat energy enters into the food and cooks it. Although radiation heating is typically the least efficient, its effects travel the greatest distance. Is there any way to speed up or slow down the process of heat transfer? Before we discuss this, don't forget to like the video and methods of heat transfer. Do you remember what they are? Take 10 seconds to think about it. The three methods of heat transfer are conduction, convection, and radiation. There are different methods to transfer heat into a substance, and the speed at which it heats up depends on several factors such as its size, the environment it is in, and its composition. The larger the substance, the more thermal energy it requires to reach higher temperatures. For instance, if we compare a steak to a brisket, both made from beef, the steak will cook faster due to its smaller size, while the brisket will take a few hours to cook thoroughly.
Now what happened? How much heat is there? It depends upon the size of that particle. Like if when you are taking a small particle of a chicken, it will take less time to heat up. Whereas if you take a big particle of that big size of the chicken, what happens? It takes more time. So size matter a lot for this process.
Personally, I prefer my brisket well done. In addition to size, the type of material being heated also plays a crucial role in the process. Specifically, metals are known to absorb heat energy at a faster rate than other materials. This is why most pots and pans have a metal
So now the first thing is the size of that object, whatever the material we are taking, that size of it. Less size, more heat. They will be taking less size, they will be taking less time to generate more heat, whereas big size or the large particles will be taking more heat to generate in more time. Now the second one is the material. What material we are using, it depends on that also. If it is metal, it is good conductor of electricity, it will be helping into generating the heat, and that is the reason like we are using the metal, stainless steel, or the metals we are using for cooking the food item, because in the less duration they can heat up and they can transfer the heat energy,
allowing for efficient heat transfer when placed on a stove. In contrast, materials such as plastic, rubber, wood, sand, and rocks are not as effective at heating up.
So we know very well if I use a sand, if I use a rock, they will not be transferring the heat energy. So they do not do that actually, because they are bad conductor of heat. Whereas the wood also can burn but does not transfer the heat easily. You might have seen, like if we try to burn the wood, it will take time. It will burn, but it will take time. At the same time, when you use a paper to burn, it will be burning within a seconds. So these
While
are
they
the
can
bad
still burn,
conductor of
they
heat.
do not transfer heat as efficiently as metal. Therefore, it is important to consider the type of material being heated when determining the best method for achieving optimal heating results. When heating something, the material's type and state of matter are both important factors to consider. Solids can absorb and transfer heat faster than liquids, while liquids can do so faster than gases. This is due to the distance between.
Now what happens? We talk about three: solid, liquid, and the gas. Since in the solid, all the particles are close enough, they will be colliding and they'll be doing the process in a faster way. Now, when we compare the solid and liquid, solid will be doing it in the faster way because the molecules will be colliding and doing it. Whereas between the liquid and the gas, the liquid will be doing in the faster way, whereas the gas will be taking more time. Why is it so? Why between liquid and the gas, liquid take less time, whereas the gas take more time for the process?
Ma'am, because of intermolecular space.
Fine, correct. So the intermolecular spaces will be there. Because of them, the movement of the particles become easy in the case of the gas, right? And if the movement of particles become easy, then it is like not possible to heat up something, right? Now, if I have three things, I have maybe I have an ice, I have a water, and then I have the only the air I have in the form of the maybe water vapor I have. Now, what happens if I take that water and if I take that water vapor? So, which will be easy for me to hold or to put it in the container? Definitely the water, right? The water can be kept in the container, but can you keep the water vapor in the container? You cannot. You can keep it, but it will be converting into liquid again now after some time. It get condenses, right? So that's the reason, like when we compare between the solid, liquid, and the gaseous state, the solid have the highest capability of doing it. Then second has the liquid. The third is the gas. Gas can do it, but not at a faster rate as like the solid and liquid. And solid will have the maximum because of the collision or the colliding power between the molecules.
Molecules, the closer they are, the easier heat can be transferred. As gas molecules are furthest apart, they transfer heat at a lower rate compared to solids with molecules tightly packed together. Lastly, the environment is a critical factor in heating a material. Things under high pressure will heat up more quickly than those under low pressure. This is the same mechanism that plays a role in the formation of stars. The gas becomes so pressurized that it begins to heat up and eventually forms a star. We covered a lot in today's video, so let's take a moment to review.
So that's about the conduction, convection, and the radiation. So, process I have explained to you. We'll discuss few points about the same. So where we were? Okay. So solid and solid. Now we will be writing about how does conduction of heat occur. How does conduction of heat occur? So it occurs because of the colliding power of it. So in a solid state, the molecules are closely arranged. So we know very well that in the solid state, what happened? The molecules will be closely arranged. Now, when a solid is heated, so when we are heating a solid, then the molecules near the source of heat will gain thermal energy. So because of the thermal energy, because of the increase in the thermal energy, what happened? The vibration will be occurring, or we can say the colliding will be happening between the molecules. So it begins the vibration faster. So collision will be occurring at the faster rate. So as soon as they come in contact with the object near the source, then they will be transferring the heat or the thermal energy, and because of which the vibration will be occurring at the faster rate. Now these molecules then collide. So as soon as the vibration start, they will start colliding with the colder molecules. So wherever the colder molecules will be there, they will be starting to collide with them and transfer the heat energy to them as well. So transfer some thermal energy to them. And what do? They will be making them to vibrate faster. Now, as soon as the hot molecules, they have passed the collision to the colder area, they will also gain thermal energy and they will also start vibrating faster. And hence they become, as soon as they start vibrating, they will become warm. And when they become warm, they will be transferring now to the next particles which are colder. So like this, it keeps on happening. The hotter, the hot will be giving it to the colder, then colder will become, they will start vibrating. When the vibration happens, they will become warm. Now this area has become warm. This area will be giving it to which area now? They will be giving to the other colder area. Then they will be becoming warm. because of the vibration, and then they will be giving to the other area. So like this, the cycle keeps on going until the whole water body converts into the equal temperature. So that is what happened in the conduction, and that is how the conduction of heat occurs. Now, two words are there, good and poor conductor of heat. So when we talk about good and poor conductor of heat, it means the materials. Okay, first we'll talk about the good conductor. So good conductor of heat, basically those materials which allow heat to pass. So the materials which allow heat to pass through them easily. So through them, what happened? The heat will be passing easily, and they are called as the good conductor. Like example, aluminum. So you might have seen in the kitchen that mothers will be using the vessels which are made up of aluminum, which are made up of iron or the copper. And you might have seen, like, when the mothers, they are doing the they are ironing the clothes, so that iron is also made up of the iron only. So that is how the heat transfer very, very soon from that. Then second one is the poor conductor. So the materials which does not allow the heat to pass through. The materials which do not allow heat to pass through them easily. So they are called as the poor conductor of heat. Example, plastic. Now, if we try that plastic should generate the heat, it cannot. Then the wood also, they are the poor conductor of electricity. And these poor conductor are also called as the insulators. So poor conductors are also known as the insulators. So plastic is a insulator, wood is an insulator. So all the poor conductor or the bad conductor, they are known as the insulators. Now, some of the practical applications of conduction. So where all we can use this conduction process? Where we can use a conduction process? So you have seen the utensils in the kitchen, right? So utensils, they are made up of both good and bad conductor. So now can you tell me why I am saying that they are made up of both good and bad conductor?
Ma'am,
Yes.
ma'am, because handle of the utensil is plastic and
Very
the
good.
utensil is made up of iron ore.
Very, very good. So utensils are basically have both the things together. They have the good conductor also, they have the bad conductor also. So with the good conductor, what happened? The heat will be passing easily, but with the bad conductor, the heat will not pass. And that is why you might have seen that if we have any vessels, like for example, this vessel is made up of the copper. Now, this vessel has what? The handle of it will be made of the substance called as the bakelite. It's a form of the plastic only, okay? So, this handle is made up of the bakelite, which is basically the poor conductor. Now, imagine if this handle is not made of poor conductor, then what happen? Easily, the heat will come to this utensil and it can go to this handle also. That is why whatever the handles are there, they are made up of the poor conductor of heat. And the center part, it is made up of the good conductor. If here also we change it into the copper, the handle also is made up of copper, then we will not be able to hold it because it will be very hot in nature. So this is the first application where we can use it. Now, second one is materials such as such as wool and cotton are used to make winter clothing. So you might have seen for making the winter clothes, they will be basically using the wool and the cotton. Or for making the blanket also, or for making the quilts also, they will be using this materials. Why? Because they are made of very thin fibers, which have lot of air spaces. Now, these air is basically a good conductor of heat. So if they have the space, air space is there. Air is a good conductor of not conductor, it's an insulator. Air is a good insulator. So that is why what happened, the quilt makers beat cotton to make it fluffy. Now, in a very easy way, if I explain you, now you might have seen, like while making the quilt or while using the quilt, you might have seen that the thickness of the quilt will be like too much, right? Now, when they make it, initially when they start making the process, when they start doing the process, what happened? Lot of air spaces will be going into the cotton or into the wool. Now, air we know that is a like bad conductor, we can say, or we can say good insulator, we can say. Now, if lot of air spaces will be there, then definitely will feel so cold. That is why before making it completely, what do? They will be taking a big object like and they will start beating the cotton so much. Now, why they beat it? So that whatever the air spaces are there between those cotton molecules, it can release up. It can go out easily. And when all the molecules of the air goes out, then definitely it becomes the good conductor of heat and lot of heat can come now inside because they will get the space. Air has occupied the space inside the quilt. Now, when all the air has been removed by heating it up, then the heat can come up and they can get stored there. That is the reason that they beat it to remove the air and to allow the heat to come inside. Fine?
Yes, ma'am.
Yashwan? Okay, so that's about like the conduction. So in the conduction, the molecules will be the solid and solid particles. When they are heated up, what happens? The hotter molecules will be moving or the colliding will be the colder ones. And when the colder comes in contact with the hotter ones, they will be converting themselves into the vibration position, and because of which they will be getting the warmth. Now, once they are being converted into the hotter molecules, and they will be passing into the other colder molecules. So, like this, the whole equilibrium state will be formed. Then poor conductor and the good conductor. Poor conductors are those materials which does not allow the heat to pass through, like the plastic and the wood, and the good conductor which will allow the heat to pass through. Whereas then where we can use this conduction process for making the utensils, where both the things are there, the insulators also and the conductors also. The conductors are present in the centers where a lot of heat can be generated, and basically the handles are made up of the insulators so that we will not find it hot when we hold it in our hand. Then second thing, for making the quilts, for making the winter clothes and all, we can use this conduction process. Fine. Okay, so that's all for today. You can start doing the MCQs. And yesterday I have gone through all the, I think, marks. Almost you all have come between 44, 43, 45, 40. So like these marks you have got in yesterday's MCQs, I'll just tell you the exact marks. Hmm. So Anubhav is not there today. Okay. Kritvik have got 42 out of 50, Yashwant 44 out of 50, and Varshit 45 out of 50. So these were the yesterday's marks. Today also 50 questions are there depending on the yesterday's topic. Fine, start doing those. And coming Sunday, you have subjective test. Which chapter do you have?
Nutrition in animals.
Nutrition animals. Yashwant, I'm waiting for your answer sheet. Last time also, the answer sheet was not submitted, I guess.
It was the subjective, right?
Yeah, subjective test it
The
is.
personal WhatsApp now.
Okay, okay. I think I have checked and sent it also, right? Answer sheet, I have sent it back. Check your number. I think I have sent it to you.
Okay, ma'am, I'll check.
And I have sent it already. To everybody, I have sent it. Right, Kritvik? You have got your answer sheet back, right? Last week?
Yes, ma'am.
Okay. So same thing this week
Yes.
also, send me the answer sheet personally also and upload it on the Wise app also, so that sometimes I face some problem on the Wise app, so I can check then.